So welcome to today's lecture on cloud computing. So today I will be speaking about infrastructure as a service, especially the AWS, Amazon Web Services. And so maybe we make a break in between and then have a second part of this presentation. We have no exercise session. So, but Andrew is here. If you have questions, you could then contact him either in the break or afterwards. Okay, good. So, about Amazon Web Services, so you might know, or maybe you are too young actually, that Amazon started as a bookstore, right? So it was an online bookstore where you could order books and send to you. And only in 2006 they actually started the cloud computing, the AWS, the Amazon Web Services. And now it's the biggest, the top cloud provider. And there are estimates about how many servers actually Amazon runs in the data centers. So for the last lecture, I looked it up. There was an estimate of 2 million servers. Probably this keeps increasing because they expand the number of data centers and also the regions. These are collections of data centers continuously, and more people actually use the service. So the start of the Amazon Web Services was the pure infrastructure as a service model, where infrastructure is offered, resources are offered, compute resources or servers. You can allocate your own server for whatever you want to do. The network, of course, to connect the servers together and connect them with the internet, and a storage service. Now this changed, and Amazon also is a general cloud provider, I would say, that offers all the service models. So platform as a service is a major aspect, I would say, because even if you are only interested in infrastructure, you use other services for managing authentication, for example, or for monitoring your infrastructure and so on. So all that are additional services. So it's really a platform now for deploying applications in the cloud. So you can find, if you follow this link, you can find a brief history of the Amazon Web Services there. So as I already said, it's now much more than just infrastructure as a service. So this, if you go to the AWS page, and you look at products, you see lots of different products here, right? And so the feature services is the compute. So the compute is down here. That is what I will be talking mainly today about. So it's the Amazon Elastic Compute Cloud EC2. But in the compute, you also have things like container services, for example, where you can run containers like managed Kubernetes cluster and so on. There are also services for analytics. So if you have an IoT application, you can use their IoT offering, combine it with their analytics services to actually do, for example, prediction or anomaly detection. So it's not that you actually have to program that anymore or host applications on your own servers. You just use a service from Amazon. So we can go down this list, So there is a blockchain, for example, business applications are there, financial management, contact centers, containers, databases are offered obviously as service, developer tools as well, front-end, web, mobile, games, Internet of Things, and so on and so on. So these are only categories, and in each category you find a number of services. And it goes down to the quantum technology. Someone of you actually mentions this in the very first lecture, that they also offer quantum computing now. So it's really a web services, so it's a broad spectrum of services. It's not only the real infrastructure that you can buy or rent at Amazon. So behind the scene, Amazon is the Amazon offer is and the hardware is structured in that way here. So basically, we have regions, and there are 26 or so regions. So like a European region, an American, West, East, South America, Asia, everywhere there are those regions, and the number of regions is continually increasing. Inside of a region, you have a number of availability zones. These are basically data centers. Yeah, and they are in a region, so the data centers are not further away than 100 kilometers, and they are connected by fast fiber optics cable. And so they are sort of a locality, right, where you can put your computation. But there are different availability zones in a region for redundancy, simply. Right, and so that is the whole point, that they want to ensure that, first of all, your applications and the services they offer are scalable, so they are distributed over regions, they are fast accessible because the regions are near to certain geographical areas, and there is some fault tolerance. If a availability zone or a region fails, the others are still working. So here is a bit more information about the regions. At the moment we have 84 availability zones, 84 cluster of availability zones. We have 84 availability zones and 26 regions, and there are two special regions, that's the US Gulf and the Chinese regions. So the US Gulf is basically only accessible to government organizations in the US, so that is for the security purposes, and it's basically a cloud that is run on the Amazon hardware, but a private cloud for the US government. And in China, we actually have two regions. That is the Beijing region, the Beijing region here, and the Ningxia or so. Probably you can pronounce this better, many of you. So these two regions are actually not run by Amazon, but by local companies. And so that is for Chinese customers, right? And if I looked it up on the webpage, there is also a link to register an account with American or other regions, but I'm not sure what the drawbacks are if you actually go for one of those regions. Obviously, these follow the restrictions of the Chinese government for the internet access. Yeah? So user can control where resources are allocated, so you can basically select in which region you want to place your resources and your data, and that might have a reason in legal requirements, like in Europe for the data privacy protection. We are not allowed to place personal data outside of Europe, right? And it can also be that you want to optimize for fast access. No? The nearer the region or the data center is, the shorter is the latency for accesses. And so that could also be a reason to select a region for your service. So the availability zones, you can think about a data center. I said this already. So what is important is that the availability zones are really sort of independent, right? They have no infrastructure common points, so that goes so far that actually they are connected to different power distribution stations. Yeah, so if one of these stations fails, then the other availability zone would still be available. So this also means, for example, that checkpointing, so archiving of data is also redundant. So it's not that two of the availability zones would archive data in the same place. So they are really infrastructure redundancy, they call that, and so by that it reduces the possibility that actually multiple of the availability zones in a region go down at the same time. So, and also for fault tolerance, you can actually spread out your service across multiple regions, so you even get redundancy across regions. Yeah, it need not be via multiple availability zones. There are also regions that have only one availability zone. So in that case, to get really fault tolerance in your application, you would have to spread it out across multiple regions then. So the naming is basically the region code plus a letter. For example, we have US East as the region, and then we have 1A for the availability zone. The mapping of the names to the zones might actually be different for different accounts. So Amazon does that to actually do some load balancing, right? But once you get your accounts, this mapping is fixed. So you know that you always go to the same availability zone when you place a server or so in that availability zone. So user can control the zone in which the VM is started, and you would do that so, as I said, for fault tolerance. But if you don't specify it, Amazon will simply select a zone to start the server. The number of zones in a region might be different for different accounts, and the communication in a zone is free. Between zones, it has to be paid. Yeah? So you might actually want to place services that heavily communicate in an availability zone. Yeah, there is some locality aspect that you might take into account when you select the place where to put a server. So, so what is nice, you basically rent the resources remotely from Amazon, but can you trust in that? Are these resources available, or might you face the problems that the availability zone goes down and your service is not available? So if you want to get industry in this business accessing the resources, then you actually want to make sure that these resources are available. And this is done through an SLA, a service level agreement, and Amazon actually offers two. So there is this region level SLA that guarantees a 99.99% region availability. So what does it mean? A region is unavailable when all your running instances or running tasks deployed in two or more Amazon availability zones currently have no external connectivity. So to actually claim that Amazon did not fulfill the region SLA, you have to replicate your services across multiple availability regions. Only if two of your regions are not available, then they would actually sort of pay, right? And in addition, there is a second one that is an instance level SLA that guarantees the reachability of your EC2 instance, so your virtual machine that you rented from the Elastic Compute Cloud. And they say instance is not available when your single EC2 instance has no external connectivity. So actually they have quite a number of SLAs available. So you can, for example, let's see, I have to switch to English here. Okay, so this region SLA, how can I? The region SLA actually covers different services, and these are the services that are covered. So it's Elastic Compute Cloud, it's a block storage, so basically this storage, let's say, the Elastic Container Service and the Fargate service here. So these four services are covered by the region SLA. And if you go through that page, you will find here, for example, what happens if they violate the SLA. So it says if you have less than 99% but equal to or greater than 99.0, so between that, you get actually a service credit percentage of 10%. So as far as I understood this page, what you get is for the EC2 service, if you use the EC2 service and it is not available, then you get 10% of your last monthly bill back, right? So they do not at all offer you some money for your lost business, for example. Yeah, if you are a bank and your servers are no longer available, then you have a bigger problem than just 10% of payment to Amazon. But that is not covered at all by their SLA. So they only offer you this service credit percentage, right? And down there is the instance level SLA, and then you find the handling for the credits here. So how this is done, you have to claim within, I think, the 2 billing periods, so you have to claim that they were not fulfilling their SLA, and then they check and might give you this credit. So what is interesting, so if you want to find concrete information what is meant by a region level SLA, you have to go to the very end of this page, SLA definitions, and here you can actually find the terminology. So for the region level SLA applicable to Amazon EC2, Amazon and Fargate and so on, when all of your running instances and running tasks are applicable, deployed in 2 or more availability zones in the same region, or if there is only one availability zone in the region and you have deployed it across multiple regions, are concurrently not reachable, then it's basically seen as a failure and would reduce a guaranteed availability of 99.99%. So, and they have also for all the services, you can find such SLAs at Amazon here. So, yeah, keep that in mind. That is something that we also ask about. So that is a recent change that they actually have the region level and the instance level SLA here. Good. So let's now look into the Amazon Elastic Compute Cloud. So what does it provide? It provides virtual machines running inside the Amazon cloud. It provides ephemeral storage that is tied to the virtual machine. So ephemeral means that it's storage that is directly attached to the server where the virtual machine is running, and the virtual machine can use this as disk storage. Then we have network accessible block storage. So these are disks which are accessible through network. And they have the big advantage that they can persist across time and can be mounted into virtual machine. So the first one, the ephemeral storage, is actually deleted when you delete the virtual machine, right? So the disk is gone simply, but if you want to have persistence for some data, you have to put it into the block storage service or something else at Amazon. And then there is also the network that is allocated for you, and you can basically specify what security mechanisms you actually want to use in the network. So for example, a firewall, a virtual firewall, you can define to protect actually your servers on the network. Good. The offering is based on the Xen hypervisor, and since 2017, Amazon is switching to their own hypervisor, which is called the Nitro. It's based on KVM, and they introduced it first for the high-end processors because the main purpose is to give more performance, right? So that the virtualization doesn't produce so much overhead as it does with the Xen hypervisor. So I have a few slides about that. So you remember from the presentation from Shashalin that we have 3 versions of virtualization that we look at here. So we have the bare metal virtualization, so the hypervisor directly sits on the hardware, and on top of that you have the virtual machines. Yeah. So, and each virtual machine can have their own operating system and obviously any software that you need. So you can run Windows on top of the same physical hardware together with Linux and whatever other operating system you want to use. So that is a bare metal. The second one is actually the hosted virtualization. And here the hypervisor runs on top of the host operating system. Yeah, and he gave examples for that. So if you are a Mac user, you might know Parallels, for example. That is a hosted virtualization. Yeah, so you basically start an application, and then inside of that application you can create virtual machines, also with other operating systems. So there is no difference from the point of view of a virtual machine here, right? So this virtual machine would not know whether it runs on a hosted environment or whether it runs on bare metal. So, and then we have finally the third one, which is the OS level virtualization, and these are containers running on top of the OS kernel. Here it's a bit different. No? In the containers you can actually run only an operating system that has the same kernel. So if you have Linux on your machine, you can run the container, and the container can have some extensions to that Linux, but it also uses the Linux kernel underlying. Yeah? So these are the important terms here, and so in the presentation I'm not that sure that it was really that clear. So there is a distinction between hosted and OS level virtualization. Yeah? Hosted really, you can run virtual machines with different operating systems, based on bare metal, but in OS level virtualization you run containers. Yeah? In a container you could have a virtual machine again and so on, so you can do many things, but that is really something different here, these two things. So, then is a bare metal hypervisor. And there you have this domain 0, that is the initial operating system that is starting the first virtual machine, and that is basically sort of the hosting operating system, and that gives services like if you want to access a disk or the network and so on, it basically goes through this domain 0 virtual machine. Yeah, and it runs a Xen management software as well. So, and in addition to the domain 0, then you have also the other virtual machines there. So it looks like that. So that is basically how it works with the Xen hypervisor, where we don't have the Nitro hypervisor, right? So you have basically this blue box is software, and the green box is the hardware here, no? And the hardware is basically what you would expect from a normal server, right? So CPU, network, whatever, memory, storage is there. And in the software, basically you have first the Xen hypervisor running, and then on top of that you have the virtual machines. Yeah, and these are the aspects that are really critical. So network I/O, CPU interrupts, and storage I/O. These are the things that then have to go through the domain 0 operating system, right? So you can see that down here in this figure, this is the hardware side, that is the software side. It's one server, we could say. And on the server we have the domain 0, it's Amazon Linux here. And we then have the virtual machine, that is the machine type, I come to that. So basically it has instance storage, so some storage available to the machine being on the hardware of the server. you have maybe this remote disk, the network disk, and you have the networking here, right? And let's say this machine wants to send a message, so it would actually go through this networking, virtual networking interface. The message would go to the domain 0, and from there it would actually go to the real hardware and then to the network. Yeah, you see the problem that we always, if we have accesses to a disk on the network, also this has to go through the network interface and through domain 0. No? So there is quite a bit of overhead involved in that. So, and that is the reason why Amazon came up with a Nitro hypervisor. So here the picture is now a bit different, right? So basically these services here are now part of the hardware. So they have special interface cards that actually support additional service in hardware. And that is, for example, they have cards for the network, for the interrupt handling, so the interrupts, and the block storage, so that is basically the disks. No? And so for now, it's possible to fully eliminate this domain 0. It's no longer needed. You only have your virtual machines sitting on the hypervisor there. And the machines have still the virtual interface, but the virtual interface would directly talk to the hardware. So any arbitration that has to be done for accessing this piece of hardware is done by the hardware itself. Yeah? And so the same if you would access storage over network, the same if there is no software involved anymore into that. So we can basically don't need this domain 0 at all, and that has the advantage that also we have not to provide any compute capacity from the server to domain 0. Yeah, so there are more virtual CPUs available for the virtual machines that run on that. No? So there is one more advantage, so it also offers limiters that guarantee the resource distribution. So for example, how much network bandwidth is given to which virtual machine is now enforced by the hardware directly. Good. So the base for using the physical servers is what Amazon calls the Amazon Machine Image. And there is, in the literature, you also find this term VM template. So that is basically a copy of the server with the operating system and then some pre-installed software. Yeah. So, and there are these AMIs, the Amazon Machine Images, are basically offered by Amazon itself, but also by third party. So there is a marketplace, and on the marketplace you can find different machine images, and you can select which one you actually want to use on in your virtual machine. So you can also define your own AMIs, of course, and these would be stored in the S3. That is a cloud storage service of Amazon, a blob storage service, so you can basically put a big chunk of data there, but you cannot, like in databases, look into that or so. It's really only a blob of data, nothing else. So you can not append something to it, you can extract it or put it there, that's all. No? And so there is obviously a bit of a problem if you, there is a matter of trust, which of these AMIs that are offered you actually choose. And therefore there are also reviews available and ratings, so to help you in choosing the right machine image. Let me go to the next slide. So you find here the link to the marketplace, and basically it looks like that, right? So you can define what you are looking for here. So you can say, I want to have a Windows-based virtual machine or a Linux-based virtual machine. Then you can select what the payment option is. So maybe you are just looking for free AMI, or you pay hourly, monthly, and so on, right? And delivery methods. And so, yeah, there are lots of options, even more, I think 32, 64-bit, and so on. So, and then you can basically select from the list here what you actually want to use. So, this is the Amazon machine image, and obviously, yeah, you want to put it on a physical server. And now we go and discuss a bit what physical servers are there and how you actually allocate a portion of the hardware, right? And so very important is the storage offered by Amazon Web Services. So there are different offerings. So you have elastic block storage, shown here in the picture, that is this here, Amazon EBS, elastic block storage. So these are physical disks that are accessible through the network. Then we have Amazon Instant Storage. These are physical disks that are connected to the server on which your virtual machine will be placed. So these are here, the ephemeral disks. So these are on the host computer, so that's a physical server. Then we have the elastic file system that is shown on that side here. So that is network attached storage, and I will explain what this is. So basically you can put files there and work with files like with other files that are on any of the other storage services, but it's also accessible only through the network. And there is a so-called Amazon Simple Storage Service that I already explained, the S3. So that is where you can actually place a block of data. So a little excursion to storage in data centers. Maybe not all of you are so familiar with that. So you know this pyramid, the storage hierarchy, and so it starts with the registers in the processor itself. Then we have the caches, then we have the memory, and then we have flash, USB memory, hard drives, and tape backup. No? And so all these layers are basically used in LRZ. So up to the tape backup, so they have big robots which then take a tape and put it on a station to read or write the tape. No? And so this is a hierarchy. Why a hierarchy? Because the lower you go, the larger is the storage space that you get. Yeah? So and this comes, larger storage space comes with the problem that latency is typically higher to access the next level. And so that latency is higher, but there is more space, and typically it's also cheaper to put data there, right? And in the middle of this pyramid here, it's annotated that this is only accessible if it's powered on, but there from the flash basically downwards, the data is also kept so persistent when the power goes off. No? So, local storage, pretty clear, you all know that. We have these spinning disks, sort of old technology, but still frequently used because they are still cheaper than SSDs. You can store more data for less money. So the problem with spinning disks, basically they are organized in these tracks here, so and then the tracks into blocks, and you want to access some information on the disk, then you have to specify which block, and then this arm here moves to the right track and then has to wait until the block passes, right? This is a spinning disk, and then you can basically read the entire block and return that to the application. So there are two delays here. First of all, to move to the track, and then actually wait for the block to come. And there are rounds per minute of these disks, 5,000, 7,000, and there are even faster ones, but more professional ones. So those that we use in our systems are typically 5,000 rounds per minute or 7,000, something like that. So, and compared to that, we see the change already in laptops. You probably, you can still buy laptops also with hard disk, but many laptops at least have an SSD for the operating system. So SSDs are based on NAND flash, and so they are smaller. They actually have faster access, and they use less energy. So that makes it interesting. So these base storage devices can be combined into clusters, and that is today really frequently done. So that is called RAID. So which means redundant array of independent or inexpensive disks. So both is used. And if you have the RAID level 0, so you have two disks here, basically they are just used to increase the bandwidth, right? So we distribute the information over the two disks, and by doing so we get the bandwidth of both the disks if you write a large set of information. So in RAID 1, we actually have now some fault tolerance. And so RAID 1 is based on the principle of mirroring. So basically on both disks we would have the same information, but it's simply copied. So that if one disk fails, you have the other disk with the information still available. And then there is also this RAID 5 that I want to show you. So it's also for fault tolerance and bandwidth. It combines both. Here you don't gain bandwidth, right? Here actually you gain bandwidth by distributing the blocks over the disks, and there is also parity information. So basically, makes the ones and zeros in a block accumulated even, I think, and so that means that based on the parity information you can lose the disk and you can reconstruct the disk from the other disks, right? And so this parity information is distributed across the different disks to increase the bandwidth, because otherwise this would always be written. So in that case, actually the parity information is written to the different disks. Okay, so that is combining the base systems together, and then we have the non-volatile flash memory, just here to show you what it actually is. So maybe not all of you know that. So these are basically these flash cells here. This is like a transistor, so you have source, gate, and drain here, and basically, so a transistor switches flow the current from source to drain, and that is controlled by the gate. So you put a voltage there, and then you either let it tunnel through, or you close the tunnel and no flow will be there, right? And in the flash cells you have a floating gate as well here, so that is not in a normal transistor, but in the flash cells this would actually keep some electrons, so you can make electrons move into the gate, and so by that they influence now the impact of the voltage that you put here to control the channel between source and gate. So that is the whole point, and these electrons, they can tunnel into that gate only with a high voltage, and you can retrieve the electrons only with a high negative voltage, and so they simply stay there, and therefore these are non-volatile memories, right? So, and there are now single and multi-level cells. So in a single level cell, basically you store 1 bit and you simply sense whether there are electrons in the gate or not, right? So it's straightforward. But to increase the density, and we are all used to have larger and larger SSDs, right? They use these multi-level cells. So in a multi-level cell, actually you have a certain charge in the gate. And by measuring the current that flows from source to gate, you can decide how much charge is there, and based on that, you can say it's 0, 1, 2, or 3, right? So you basically can store multiple bits now in one of these cells. That comes with a problem of a higher bit error ratio, and it also comes with lower write speeds because you have to be more careful when you actually push the electrons into the gate. Okay, so data center storage, that also changed a bit, this aspect. So before, everything was about how much you pay per gigabyte, or terabyte or whatever. So gigabyte. And so the disks, it was important that they get larger and cheaper, so the money you pay per gigabyte goes down. This is no longer the case, and part of that is also cloud computing, so it's server consolidation. Yeah, so that is also what cloud computing is about. So you place multiple servers on the same hardware. Instead of just having one server for one purpose, you now have multiple servers. So what does it mean? That means that your I/O system is much more heavily used by the virtual machines sitting on the server than if you have only one purpose there, right? And these are not only big information that you actually retrieve from the disk, but it's actually that all the machines go to different parts of the disk, right? And so it's important to service more I/O operations per second. And that is now the metric, euros per 1,000 million I/O operations per second that drives the market. And there are enterprise solutions, so you clearly have all disk-only systems, but more interesting is that your flash also used there already, so you have all flash arrays, so these are basically storage racks where just flash devices are in there, or there are these hybrid flash arrays where the flash is used, for example, to store written information until it can be propagated to the hard disks. So the advantage of the all flash is clearly so that you have a higher I/O operations per second, and you have lower latency and higher bandwidth than in disk systems or in hybrid flash arrays. You can combine the individual SSDs also into RAIDs, for example, but obviously they are more expensive because hard disks are cheaper in the sense of the amount of information that can be stored, not cheaper in the sense of the I/O operations per second. So how is storage provisioned in a data center? And that is what Amazon does. So you can, first of all, you can have direct attached storage, right? These are storage devices which are connected to the server. So, and that typically leads to over provisioning. So you have more storage available to be able to serve the needs than you actually need. Yeah. Then the data centers introduce the storage area networks. So that is basically a network that provides access to block level data storage, so disks. Yeah, and so typically this is a specialized network that is also independent of the local area network that connects your servers together. Yeah, it's really a dedicated network with dedicated fiber optics that connects the servers to these storage banks, let's say. And there is no file abstraction, but you only have block level operations. So like in the disk, that what I explained, you can read a block, you can write a block, you do that basically over the network. It's the same. So the disk is not directly attached to your server. Good, and then this enables actually to look at this as a shared pool. Yeah, and so you have a shared pool, hopefully, of spare resources, and from that you can service requests for additional disks. So, and the third option is that the so-called network attached storage, or NAS. So that these are storage devices that are also connected to the network, but they are connected to the normal network, the LAN. And these are basically file servers. So you have a file system on this storage, and you can now execute file operations on the files that are located on the remote storage. So maybe who has a NAS at home? Probably some of you should have, right? Okay, yeah. So there are some, no? So it's quite convenient. You can easily put backups or so there, or information that you want to share with other people. Okay, so this is a picture for the storage area network. So this is the old-fashioned approach here. You have 3 servers. Each server has its own disk with size 500, 500, 500. But actually the applications require 100, 100, 1000. So these are 1200. We have 1500 in total, but we cannot satisfy the 1000 because we have only one disk on the server, and which is too small. So that is a problem, and so it leads to over provisioning. You make these disks larger and larger, and a large portion of the disk is not used at all. No? And so in the data centers you have this storage area network, which is shown here as a box. You have disconnected that, but you have logical units here, and these logical units basically resemble a disk, a physical disk, right? And so the logical unit number is given to a server, and this looks like a normal disk, a physical disk connected to the server, and you can then execute block operations like in this here. You can access a block on this logical unit, and this would actually go through a specialized network, and that is this fiber channel networks. Most of these systems are based on this protocol, the fiber channel protocol. There are special links, special routers for that, and they connect the servers with the physical storage. Okay. So, and with that, we are now quite flexible. We could even partition disks into 2 parts and give a smaller part to one server and a larger part to another server. We could move the smaller part between servers, and by that making space to actually increase the space in a disk and so on. So there are lots of options here available. It's a shared resource, these disks here, and that is obviously what Amazon also needs, right? So you have all the servers, not only 3, but you have thousands of servers in a data center that actually want to access this. So, I spoke about besides fiber channel, there are others as well. So the storage device is visible to the client as a normal disk. So you know what, if you put a disk into your system, you first have to format it, right? And by that you put a file system there, and then you mount it into the tree on your system, and then you can basically read and write files. No? So there are drawbacks. So you share this bandwidth in the special network there. You share the performance, obviously, also of the storage devices. So maybe other servers are using the same storage device. And there are also security concerns because you have the transfer of your data through the network, and that might be vulnerability. So, and then there are the advantages. So you have flexible distribution of devices between clients. So you don't even have to change cabling. So if a disk fails, you simply use remap the logical unit number or give a new unit number, and that's it, right? So you don't have to go to the physical machine and change physically a disk. No, that's no longer necessary. So that's the replacement of faulty servers. So if you have a faulty server, you can simply put it on the new server, and it accesses the same unit, logical unit, so it would simply start up and continue. So, and there is also easier disaster protection. So yeah, that means you do backup centrally. You don't have to collect the information from the individual servers. You just back up your storage in this storage area network, and you're done. So the other one is the network attached storage. So we have a file server here, and whenever one of these clients actually want to access a file over a path, a directory path, right? So it might send the request to the file server, and the file server is then responsible to fetch the information from the disks that are attached to it. So yeah, there are different implementations of that. So in the picture you saw a computer, but this computer can also be a small embedded system, for example, or an ASIC, so a special purpose chip that takes care of all these operations. And so access to the files works through a network file sharing protocol. Typically it's NFS. And frequently used internally in a RAID for the disks, so to get some redundancy. And you can also cluster these network attached storage together, so to actually distribute files across multiple of these NAS servers. So then the next topic would be storage virtualization. So there are two aspects here, and that is important. So we have block virtualization and file virtualization. Block virtualization basically means you access a block, but it can be here or there on the disk in the storage area network, right? So basically you have some, this guy would say, oh, I need this block logical unit number with the block number, would send it somewhere, and somewhere else is decided, oh yeah, I have to go to this disk and fetch the information from that disk, right? So, and this is basically about the metadata that determine the mapping of the virtual disk and the block number to the physical disk and block number. And so then I/O redirection is done based on the metadata. So what is nice about that is that you have a flexible mapping, so you can map the block of a virtual disk to whatever physical block on a physical disk. That enables the SYN provisioning that I said. So at the beginning you provide a disk with a certain size, and then you can easily increase the size of this virtual disk, because the blocks even don't have to be near together on the physical disk anymore, right? So you can now really go from a block on one disk to the block on the next disk, and in the virtual disk it looks like as being the next sequential block, right? So you can expand and shrink this. You have non-disruptive data migration, so you migrate data from one physical disk to the other, and you just switch the mapping information, and it's done. No? And with that flexibility, you get an improved utilization of your hardware. So, and the implementation can be host-based, so that the host basically, when who has a virtual disk, knows about the mapping and would send the request for the physical unit. It can also be storage device based, so that the SAN actually knows about the mapping and would decide. And it can be network based, so you might have special servers in the network that do the mapping. They reply with the information of the mapping between virtual disk and physical disk to the host, and then the host would actually access directly the hardware with the physical information. And so that there is this in-band and out-of-band implementation. In-band means every request first goes to the network server who does the mapping, and then continues to the SAN, or out-of-band where actually the information is provided, the mapping information, to the host, and the host would then directly send the physical request. Good. File virtualization basically means that on the NAS you can have different file systems, obviously, and so you can actually access files in a transparent way, so you don't need to know on which NAS it's actually located, but there's an intermediate layer where it's decided where the file can actually be found. So this is shown here. We have here the DFS server, distributed file system, Microsoft, and then from here it's basically decided where the request has to go, on which of the physical NAS servers here the file is located. Good. So now we go to Amazon Block Storage, and you understand why I was talking about the storage area network. So basically, the block storage is based on storage area network. It's really giving you access to the disk in the blob of the storage area network, and so these are formatted then as appropriate. So you basically get this for your virtual machine. You get access from your virtual machine, then you format it with a file system fed or whatever, and you can even allocate multiple of these disks, virtual disks, and then combine them into a virtual RAID. That is possible. And if you want to do backups, the snapshots of the block storage volume are stored in the S3 for backup. So then we have the Amazon Instance Storage. So these are, as I said, the disks that are attached to the physical host. And if you stop or terminate the instance, the data are basically lost. And you have different instance types. So these are the physical machines on which, these are the virtual hardware, let's say, and the virtual hardware can have as instance type normal disks or NVMe or SATA-based SSDs. And there are the more powerful instance types actually have an SSD support to deliver high random I/O performance. So that is about the IOPS, right? Good. And finally, we have the elastic file system. That is basically a NAS and a scalable file storage. You can create it and mount it into your instances. And that is a way, if you want to share files between virtual machines, you can do it through the elastic file system. And so the disks are only attached to a single system, so the files there cannot easily be changed, but here with the elastic file system that is not an issue. Okay, and then the file system has to be explicitly created and destroyed. So you basically create this elastic file system in your cloud instance or your virtual private cloud, and then your machines can actually access this. So, and finally we have the simple storage service. As I said, it's for storing big blobs of data, so from 1 byte to 5 terabyte you can put there. It's reliable, so it's replicated, the information that it's never lost, and it's also inexpensive compared to the block storage, the EBS. It's a very simple structure, so you basically have a 2-level namespace. You have a bucket, and in the bucket you basically place your files. And it's slow compared to local disks and the elastic block storage. You can access it inside of the EC2, but also from outside through an API. And it has high durability but low availability, so it might not be immediately available when you need the data. And most users use the S3 only for short-term or long-term backup, or the AMIs, the Amazon Machine Images, are actually also stored there. Good, and so maybe we have a short break now. Right. Yeah, let's have a break of 10 minutes. So if you want to talk to Anshul or just get out and relax a bit and then come back in 10 minutes, we continue at 3.
Hi, Professor.
Yeah.
I'm honored, and I have a full AWS license to cloud practitioner and cloud architect. And
Oh, okay.
yeah,
Yeah, so you know all that, right?
yeah,
Okay.
but there are lots of details about this. I mean, for example, S3. I just worked maybe 10 days to just learn S3. Like there are Glacier, AWS S3 Glacier, lots of things. But already to just teach us, over and surface level, or give more details, you will give more details.
I also have a chapter on cloud storage where I also look at Glacier, for example, right? But then also it's a databases, offerings of AWS, right? So,
I mean, yeah. Because there are lots of details about it, for the
Can you imagine,
for network, database, storage.
Yeah.
It's endless, lots of stuff,
Okay, so
So I mean,
you are working at Amazon, you said, or
no, I'm working on Intel.
At Intel. Okay.
But yeah.
And what is the purpose of Intel being interested in Amazon, because they run the servers, or?
I mean, I also got acceptance from Amazon, but I choose Intel. Because my project, was better than Amazon. I'm working as a DevOps engineer there. I'm also doing some debug stuff, testing on new GPUs. I mean, Intel producing some GPUs as well, as I'm working on it.
Okay.
Yeah. With my field.
Okay.
Yeah, but also
What is your experience?
in terms of what?
Performance?
Actually,
Difficult to say as an
yeah,
Intel person, right?
I'm working as a work student. I mean, I don't have serious experience because
Okay.
I directly graduated from bachelor and I started to work in Intel and also doing
Here
my
in
master.
or?
Yeah, Lilienstraße. Lilienstraße. There are 3 sites in Intel in Munich.
Okay.
One of them is as you say it, and the main campus is Lilienstraße. It's around in Canton, I guess you know it. But everyone is working remotely.
Okay.
It's hard to learn something because when you touch someone, you can directly learn it. When everyone's working remotely, it's hard to touch other people. But there are lots of stuff.
Yeah, so if you want to get the details of special services from Amazon or so, that you might not find here in the class, right?
Yeah, of course. But you're teaching very well, I guess, and it's very fun. And there are always things to learn. For example, I don't know their architectures. You're also explaining their architecture. I was just knowing in terms of knowledge, but it's also good to learn their architecture.
It's also quite fast evolving topic.
Of course. It's always developing, updating itself.
If you see the list of services that Amazon is offering there, right?
Right.
So it's that's quite interesting. Also have a bit of about security, but I did not combine it into this presentation. So let's see next time.
How about the exam? There are lots of numbers. It's my first term in and,
Okay.
and I'm just wondering which points should I give more, time, focus.
So that is always difficult, but
What's the technique?
so, and what I think what really is important is to be able to discuss these topics, right, and to know the terms that they're introduced. So with this strategy, I think you will do well.
Oh, really?
Yeah.
Okay.
Yeah, but this requires also quite a bit of dedication to learn these things. Yeah, there's quite some material here. There are also the exercises, right? But I think this, would be the best approach. Yeah. So, for example, you would ask what a machine image is. Amazon machine image.
Definition,
Right?
maybe.
Yeah, you should know that it's operating system plus applications, right?
Yeah.
So it's not the hardware, right? The hardware is a separate story. Yeah? So these things are important, right? Yeah. So
Fundamental thing.
right, yeah. So at the end, you know about what is function as a service, how is it implemented. We talk a little bit about the implementation as well, right? And so I think in that sense, you really have to know more or less what was presented in the lecture. And from the exercises, as we said, so to know what was on the slides is sufficient, but maybe to practice a bit is
search
also
maybe,
helpful, right?
Of course. I mean, the best learning method is searching. Alone because you can teach everything in one lesson.
I mean, what I really like, if I would have to learn that, I would basically I don't know whether you know, there is software where you can actually take the PDF and you can basically extract the micro. For example, you can create these cards there, right? And then you run it, right? So after extracting everything, you know it anyway already. Yeah. So
Right.
that is the important part, to sort of and I think it's difficult to only start learning it at the very end before the exam.
Yeah.
Because then it's a lot of terms.
Yeah, of course. I'm always studying for them. Every day.
But we always try to not make it
Very
unfair
hard.
to the students.
I mean,
So
it's
that
very
is-
fair, I guess, projects in course as well, because you can manage if you just study too hard in a day or 1 hour.
Yeah, okay.
Nice to meet you. All right. Guess you can start.
So we have, I said 3, right?
Yeah.
Time. Okay.
Nice.
Yeah. Yeah. That's good. So basic stuff, copying, computer science. Probably only what I said. hope that was clear. I mean, it was quite a bit I mean, other features are required on the hardware, so that would be interesting to go even deeper, right? And we have Okay. Good, let's continue. So we learned about the Amazon Machine Image, right, which is the software that you put on the server. Now we learn a bit about the hardware. These are the Amazon EC2 instances, and so yeah, an instance is basically running a virtual machine. A running virtual machine, so which is defined, it's executing the AMI, right? So there are different instance types, and these are the virtual machines with different compute and memory capabilities. So how many processors you have available, how many physical memory is there, main memory, no? And whether there are disks, what type of disks, and so on. All that is part of the instance type. So, the storage of a virtual machine there you have the boot device volume. So that is a volume where you actually put the boot partition, right? And that can be on two places. It can be in the block storage or it can be on the instance storage. And you have instance volume. So these are local disks that you can use for storing data. And both of these, so as the boot device volume as well as the instance store volume, are lost when you terminate a virtual machine. Yeah, so they exist only as long as the virtual machine is ready or executing. And if you want to have data that persists beyond the existence of the virtual machine, you have to use the elastic file systems, the NAS implementation, or the EBS, Elastic Block Storage, so that is a ZAN of Amazon. So here you find a list of instance types, and I want to go there for a moment. So you will see that we have a large number of instance types. So it's really a challenge a bit for you as a user of the cloud to decide which instance type is actually the best for you. Here we have as the first one based on Mac hardware, but let's go for, and it says here we have an Intel Core i7 processor here with 3.2 gigahertz, 4.6 gigahertz turbo. It says there are 6 physical or 12 logical cores, so it's hyper-threading, right? You have 32 gigabytes of memory, and you have instant storage available via Elastic Block Storage, and these are Mac instances which are accessible through the EC2 cloud. So you see these specifications, whatever we select here, like the T2 for example, it's an Xeon scalable processor, it's an Haswell or Broadwell processor, with 3.3 gigahertz, burstable, and so on. So you basically know what you actually get for that. And so you can here look into the table. So you see you have a T2 Nano, which has only one virtual CPU. Then we have 0.5 gigabytes of memory available. And for storage, you have only the EBS option here for instance storage, right? And also the network performance is specified, so you can have instances that have a better, more bandwidth connection than actually other instances. No? And here it goes down to the T2 2x large, 8 virtual CPUs, 32 gigabytes of memory, only EBS storage as well. And so you have also compute optimized, for example, yeah, so these are then based on the Graviton 3 processor. You have systems that are based on AMD EPIC processor and so on. Yeah, so you basically know what type of hardware is in there and how much virtual CPUs you actually get for this virtual machine and the memory and networking. Okay, good. So it's then obviously a challenge because the more powerful instance types are more expensive per hour, right? And so you have to select what you actually need to not pay too much. So for the EC2 instance, you can get an elastic IP address. So you have private and public addresses. The special for the elastic IP address is that it's a static IP address. It's reserved for you. You might want that your service is reachable at a certain IP address. So then you reserve this IP address and then you can use it and map it to a virtual machine that you start. And so you pay for this address independent of the usage. Only the reservation of the address comes with some costs, and if you actually use it and map it to a virtual machine, then you don't have to pay for this elastic IP address. If you don't use it, it's not mapped, then you actually have to pay an additional fee. So, and if you have an account at Amazon, there are some quota with the account, and these quota actually might limit the number of virtual machines that you can start and also which types you can use. So you know there are these free accounts and they actually allow you to access only the very low power machine types. No? Okay, good. The life cycle of such an Amazon instance, so the virtual machine, running virtual machine is like that. So here is the Amazon machine image. You launch it on the hardware, so it goes to that pending state. Then it goes to the running state, and in the running state you have now the option to reboot, right? So you can go here and then it continues running, or you can terminate it, so you shut it down and then it's terminated, and as I already said, all the instance storage is left basically. And for so-called EBS-backed instances only, so that these are instances where the root file system is in the elastic block storage, you can also stop the machine. And then it goes to the stopped state and you can restart it, and then it goes through this pending state back into the running state. Yeah, so these are two different types of machines. So the ones that are EBS backed and those that are not EBS backed, and that is an important difference. So let's compare that. So the boot time in the pending state is actually here usually less than 1 minute if the root file system is on the elastic block storage. While if you basically have an instance store backed machine, it takes less than 5 minutes to boot it. The reason is that the whole image of the root file system has to be copied to the instance store, and only then the machine can start. In the other case, you can already start, and then sort of a demand fetch mechanism is used to copy things into the root file system as needed. So here there is a size limit for the root device. 16 terabyte. This TB byte, maybe you note, that is a precise 2 to the power of 40 bytes, but I'm used to this 10 to the power of 12 for terabytes. So we have 10 gigabytes here, so much smaller. Then the root device, as I said, is in the EBS here. Here it's on the instance store. The persistence is by default, the root volume is deleted when the instance terminates. So that is what I said, that we lose the root device, but we also lose all the instance storage. Data on any other EBS volumes that you basically mount into your virtual machine persist after instance termination by default. On that side, all the instance store basically is lost when the machine is terminated. But if you mount EBS volumes into that, these will also persist. So, modifications, the instant type, kernel, RAM disk, and user data can be changed while the machine is stopped. Here, actually, these attributes are fixed. So the machine on which the virtual machine is really executed and the capacity here in terms of virtual CPUs and memory can be changed. You can stop the machine and then restart it on a different machine instance type. Right, and the charges, basically you are charged for instance usage and for the EBS volume usage, and storing your AMI as an Amazon in the EBS snapshot. And storing your AMI as an Amazon EBS snapshot in S3. You are charged for the instance usage and storing your AMI in the S3 if you want to do so. So, and the creation bundling, a single command call requires installation and use of AMI tools. In the stop state can be placed in stop state where instance is not running, but the root volume is persisted in the Amazon EBS store. And this cannot be placed into the stop state. So you you can reboot it, but then you can only terminate it, so not stopping it. So for the life cycle and the billing, so if it's in the pending state, it's not billed. If it's in the running state, it's billed. In the stopping state, so the EBS backed up systems are not billed. If preparing to stop, billed. If preparing to hibernate. So if you stop it, then this is not paid. Yeah, so the stopping state, so the pending state. But if you want to have it hibernate, so that actually the memory contents is also saved, then you have to pay also for that time it's in the stopping state, and when it's stopped, it's not billed at all. No? So you can have a virtual machine, you stop it, and then you restart it when you need it again. That is the advantage of the EBS. So shutting down, so that is not billed, and terminated definitely is not billed. So it's basically deleted then. So here this compares a bit the aspect if you stop it and here you hibernate it, right? So you basically save also the memory contents of the virtual machine into the EBS storage. So the host computer for these virtual machines that are EBS backed, you can stop it and then the host computer can be changed. Yeah. Only if you reboot, it stays on the same host computer, but if you stop and hibernate it, it might go to a different physical machine afterwards. So what about the addresses, private and public IPv4 addresses? These addresses stay the same when you reboot it. On that side, the private address stays the same, but it might get a different public IP address. If you have an elastic IP address connected to it, then this will stay. And so there is no difference here to the hibernation, and if it terminates, it has no IP address anymore. No? The elastic IP address remains associated with the instance. The same happens here, also in the hibernate. And if you terminate it, the elastic IP address is disassociated from the instance and can be given to another instance. For IPv6 addresses, the address stays the same. The instance keeps the IPv6 address, and the same here for the hibernation and termination. There is no address connected to the machine again. So the instance store, when you reboot, the data is preserved on the instance storage. No? The data is erased if you stop it. Only the root device is saved. In hibernation, it's the same, and on termination, the data is basically erased. For the root device volume, I said, no, this is preserved here, and the volume is deleted by default if you terminate the machine, but you can override this so that the root device actually is saved as well. The RAM contents, RAM is erased when you reboot, no, like in any other computer. The RAM is erased here if you stop and start, so basically you stop the machine and then you reboot it. And the RAM is saved here to a file, no? So that is hibernation. You basically save the RAM contents and then you can start from that position or that state what the virtual machine was in. And here the RAM is clearly erased when you actually terminate it. The billing, the instance billing hour doesn't change here, so by rebooting, you simply continue the hours that you use it. You stop incurring charges for an instance as soon as its state changes to stopping. Each time an instance transitions from stop to running, we start a new instance billing period, and the billing minimum of 1 minute for every time you restart your instance. You incur charges while the instance is in the stopping state. Now we do hibernation, so we have to save the RAM content into the EBS as well. And then it stops. While it's in stop state, you don't pay for the virtual machine. Okay, and when you terminate it, you don't have to pay afterwards. So, this is for the instances, and I have a little bit also about the pricing later on. So for the security, that is a little bit a high-level view on the security. So basically all the accounts now go into EC2 VPC, a virtual private cloud. So the virtual private cloud, you basically launch your resources in the virtual private cloud. It's like you are on an own network in your own data center, right? And you can configure, for example, for the virtual private cloud, the IP address ranges. You can create subnets, routing tables, network gateways, security settings, and all that can be defined for this virtual private cloud. And you can then make also a connection to the internet, but you don't have to. And you can even connect the virtual private cloud to your own data center. So, and Amazon will create a own virtual private cloud for each user, but you can also create other virtual private clouds and later on. So the access to EC2 is basically through web services API, but there are also interactive tools available. So there is a web service console, which is shown, I think, here on the next slide. No? So it's a web interface where you, for example, can look at the instances that you started, or you can launch instances here. There are also command line tools to start virtual machines and control all these services. There are also third-party infrastructure tools. So for managing a whole infrastructure with multiple servers, accounts, and reports, etc. So yeah, you want to, for example, put accounts on multiple virtual machines, then you can use the tools to do so across the virtual machines, even across different cloud providers. Yeah, and that is the business of a company called, it's now Flexera, but it was RightScale before. So these actually offer you a management interface that can spread across multiple cloud providers. Yeah, so you don't have to use the specifics of these individual cloud providers, but can use their console to control all your infrastructure in the different providers. And typically you access the servers by private and public key pairs that you create for it. So the console I already showed you. You can imagine that setting up your virtual machines manually through the console is quite cumbersome, and so you might want to actually define how the infrastructure should look like, and even keep versioning for this definition, right? So that is called infrastructure as code, and then you can put this code into the versioning system so that you always keep track of what infrastructure is necessary for your deployment. So, and that is enabled by the tool CloudFormation service. You can specify all the resources in a textual way as a JSON template. It allows, for example, an institution to create also custom templates that then used by all users of this institution. For example, it can be used for the automatic deployment of all the resources in a controlled and predictable way. No? So you start setting up what you specified with one command, and it will then be implemented on the Amazon infrastructure. And you can either do that with a code editor, and you can use versioning tools besides the code editor and really having to type the JSON specification. You can also use a graphical interface and basically put here your servers, your objects that are running in the AWS, and you can connect it, you can specify the gateways and so on. All that you can put together in this graphical tool. So now we come to the pricing. So there is on-demand pricing. That's what you would expect, right? So you decide, oh no, I need a virtual machine, so I get it immediately and I have to start paying for it. So let's go to the link here, and you see that for the different virtual machines, for the instance types, you can see what you have to pay, right? So here, for example, so we have the A1 medium, which costs you like 2 cents, 2.5 cents per hour, and yeah, it goes down here to the larger types. Actually, this is, here we have 40 cents per hour for the A1 metal. So they have then more compute capability and more memory, but you also have to pay a higher hourly fee for it. No? So that is how it works. So, and you can see from that table already that you have to pay for many things. So it's actually not too easy to keep an overview what your infrastructure actually costs you. So there are also tools available at Amazon to calculate the potential costs of your infrastructure. So let me go back to that. That is on-demand pricing. So while you use it, you actually pay for it, right? They also offer the so-called reserve instances pricing. That is then cheaper. So that means that you actually reserve instances, and you can see that here in the table. So if you look at, for example, the A1 medium, again, you see there is a monthly fee of 11.75, and then there is an hourly rate that you have to pay, right? And so with that, you can save compared to on demand for a certain usage. I don't know what is behind these numbers. So you save 37% for that compared to the on demand rate, no? So 0.0016, and here it's 0.0255. But you have this monthly fee for the reserved instance. So if you use it, then you can actually cut your costs. No? If you don't use it, then maybe this monthly fee would actually dominate the costs then. So that is a reserved instance. So you can profit from reserving instances and giving Amazon more information what you need. And then there is also this pricing spot market, quite interesting. So on the spot market, that works like that. So Amazon determines the market price. So let's say they have capacity and they want to fill the capacity. So they actually give you these virtual machines for a much cheaper price. Yeah? And so they publish the price, and so you see that this price changes over time depending on how much additional unused capacity they have, right? So they recalculate from time to time the price of the machines. And you actually bid for a machine, so you say, oh, I'm willing to pay for a machine on the spot market, let's say 6 cents per hour, right? And as long as the market price that Amazon actually publishes is below that, this machine will be yours. As soon as it goes up here beyond 6 cents, it will simply be taken away from you. Yeah? Without notice, so you have to be a bit careful what you put there and to be able then to restart whatever computation is there somewhere else. So, right, but this is dramatically cheaper, so if you follow the link, you can actually see the numbers, so quite some significant cost savings are possible here, and you have to sort of understand how likely it is that actually it will be taken away again, because the price actually, the market price goes beyond what you are willing to pay. Good. Then you pay for data transfer. So from the internet, any traffic going into is free. For traffic out to the internet, you pay 9 cents per gigabyte. Inside an availability zone, by using the private IP address, you don't pay anything. Regional transfers via the private IP address between different availability zones in the same region cost 1 cent per gigabyte in and out, and if you use, instead of the private, you use the public or elastic IP address, then it's the same price, but this is a different, in principle, a different pricing scheme that they have here. Yeah, so it's also not, you have to be very careful how to set up your traffic, how much traffic will be between availability zones out to the internet, which IP address you use, and all that influences how much you actually pay. So for the block storage you also pay, no? So for example here, this might not be the current value, so 11 cents per gigabyte month for provisioned block storage on SSD. You see the hard disk is cheaper, right? Then you pay for provisioned I/O operations per second months as well. Then for the snapshot S3, you pay much lower only 4.5 cents for gigabyte months for data stored, not for the provision storage. So for the block storage, you say I want to basically have access to so much. So you pay for the provision, not only for that what you use, while here in the S3 it's only for the data, for the storage used actually. Then you pay for put and get requests here for the S3 as well. Put means you put something there, get you retrieve. That's the only thing you can do with the data in S3. And for the elastic IP address, this is a static one that is bound to your virtual machine, and so reachable from the internet in a predictable way. So the next is not paid when you really use it, but if you don't use it, then you pay per complete hour 0.5 cents. And you pay for the remapping as well. So the first 100 remaps are free, but then for the next 100 remap operations, actually you pay again. Yeah. So that takes me to the end of this lecture. So I try to give you an overview of the Amazon EC2, so the infrastructure as a service offering from Amazon, where you can allocate virtual machines, you can allocate storage in the different ways, the block storage, the S3 storage, you allocate the network, you control the network, and you have to decide what instant types you use. First you decide which Amazon machine image to use, then you decide which instance type you want, and then you can basically start the Amazon machine instance image on the type, and you get an Amazon machine instance. Okay, and then we discussed also a bit about the pricing, that there are the different models for pricing, the on-demand, the reserved, and the spot market pricing. And experience shows that Amazon, using the Amazon Compute Cloud is not always cheap, right? So compared to having your own infrastructure, and so you really have to benefit from that enough by dynamic usage, that you want to scale your application dynamically. For example, you have periods where you don't need so much infrastructure, periods where you need more, so you don't have to pay for the hardware the entire time, let's say. That is one aspect. The other aspect is, of course, you don't have to care about the hardware. That might be also benefit, and also you don't need the personnel for running all that. So look at LRZ, they have a large number of people that do nothing else than having the hardware up and running, the cooling system up and running, fixing problems here and there. So all that you get rid of if you go for such an infrastructure as a service offering. Okay, so thank you for being here today, and then we continue next week.